Hi. Hi. Yeah, I'm super happy to be here today. It's really exciting. It's my first time in Florence. Not my first time in Italy, but my first time in Florence. And I'm really happy to talk in front of so many people. My name is Alina Dima. I'm a senior developer advocate in the AWS IoT ecosystem services team. I will tell you a little bit about what our team does in the next slides. But today what I'm going to talk about is IoT and edge resilience. How many of you in the audience have worked in IoT? Okay, that's quite a few. How many of you have worked with AWS IoT? Okay, that's nice, cool. Yeah, so I have an introduction as well, so don't worry if you haven't worked with IoT. So I'm going to introduce IoT, MQTT, and then I'm going to talk about what can go wrong at the edge. So generally, when you're building IoT, multiple components, an ecosystem, we'll talk about that, but we will focus on the edge. Then I'm going to explain how you can solve some of these reliability problems by building resilience in your application, and how you can do it with, of course, open source tools. I mean, starting from the protocol itself, if you're using MQTT, for example. MQTT has a lot of resilience built in that a lot of application developers sometimes are not super familiar with, and some things get, they just fall between the cracks. So we're going to talk about that. And then we're going to look at IoT Device Client, which is a modular C++ open source application provided by AWS with best practices. I'm also going to talk about other tools like MQTT.js, which is also, again, a tool that you can use, which is, of course, open source. It's a library. You can build it in your application to achieve resilience. Right. So, I mean, I've been already introduced. Maybe just one thing about me. I worked as an engineer from when I was 20 years old. I had my first job. I moved to Berlin from South Germany. And since then, I have moved from building Java distributed applications to JavaScript. I had my first JavaScript shock with, non-type defined and variables being anything. So that was interesting. And then I switched towards serverless applications. And I'm actually honestly fascinated by serverless technologies. And how you can just focus on building your application while other things like infrastructure can be taken care of for you within the limitations, because you still have to take care of scaling yourself, which is the fascinating part, or one of the fascinating parts. Right, so what are we going to do in this session? I mean, I want to focus a little less on technologies and tools, and not so much on AWS services. I want to focus more on the idea behind resilience. So why does it matter? What are the challenges that you encounter in IoT that sometimes you don't have in other solutions? And how can you fix them? So when you know what the challenges are, then you can make informed decisions about the tooling that you can use, right? So the important thing is to know about it. And then we can look at some tools just as examples. And I will build a little short maturity model that you can take with you when you're building IoT applications. It's going to focus on the edge. Right, so IoT, billions of connected devices out there, all speaking different protocols, connected by different technologies with different type of constraints, from really small microprocessors to really powerful gateways. All of them need to work. Sometimes all of them need to be managed within the same fleet of devices, which is very challenging, of course. And if you are building an IoT use case, you're not building IoT for IoT's sake. What you're doing is building IoT to build something else, to get maybe some data in order to understand operational models of your devices, of your factories. Maybe you want to improve your house experience, right? So you're building home automation, you're building, controlling your I don't know, fridge and microwave, and a little robot bringing your newspaper in the morning, and the coffee machine turning on automatically, which would be really great. So it's always about what you get by setting this foundational technology in place. So this is very important. Of course, this only works if what you're doing is reliable, right? So if you're getting data out of microcontrollers, if you can trust that data, then you can build something out of it. But if your data is not trustworthy, then you literally have almost nothing. If you've got, I mean, I worked in projects where multiple teams were working together, sometimes the same companies, sometimes different companies. You interact with hardware vendors, you interact with connectivity partners, you have a machine learning team or data engineers, And there's always a bit of finger pointing between different teams when something goes wrong. And the reason why there is finger pointing is because sometimes reliability is missing at different stages in the application. So data engineers would come and say, hey, I don't have the data, what have you done? You know, I'm getting null values, but I'm actually looking for meaningful integer values, for example. So what is really going wrong, and who is responsible for fixing it? Right, so to have reliable applications, you need to build resilience in. Now, IoT is different because here we are dealing with an ecosystem, right? So by ecosystem, we mean hardware, software, network protocols, of course, cloud components as well. And they're all provided by different people, right? It's open source projects, we have technology providers, we have, I don't know, if you're using, for example, cellular connectivity, then you've got your SIM card provider. If you're using a microprocessor, you have the hardware provider as well, and so on. So all these building blocks need to integrate and work together. There are multiple phases, especially if you're building something for production. You've got your planning phase, you've got your building phase, and of course you've got your running phase. And the people responsible for each of these different phases are different, right? So an operator expects different things from a system than the person who built it or the person who planned it. So what are the challenges for engineers who are working in this field? Well, the multitude of technologies and protocols, right? So there is so much out there that very often developers don't know what to choose. And you need to, of course, try and do POCs with different technologies to understand if it is the right thing for you. Some technologies are more stable, some others are potentially less stable, but they might still be what you need. For example, if you know that your devices need to communicate 24/7 with your backend application, be it in the cloud or be it running on-prem and so on, then you know that you need a protocol that is designed around real-time communication. So sure, you can use HTTP, but that's forcing the node because you just know that you need this channel open. With HTTP, you need to actually establish a session every time that you're sending some data. So this might not make any sense, right? You opt sometimes for event-driven architectures if this is what your solution needs. Of course, it's not always easy to identify problems early. So what you have in your testing lab is very often not what happens when your devices are out there with the customers. So you've got external factors influencing, like for example, your connectivity provider, your internet provider drops the internet connection entirely. And that drop is, let's say, for 2 days. Or your devices run out of battery and they are offline until you go and change the battery. A lot of things can happen when your devices are out there in the field, and you need to mitigate for these kind of scenarios. We're going to look at that. Of course, if you're using the cloud, you've got a shared responsibility model, right? You, as an application developer, are responsible for what your application does, right? So are you following best practices in terms of security? Are you following reliability and operational best practices? And of course, the cloud provider is also responsible for the security within the cloud as well. But of course, there is a shared responsibility model between the different teams, right? So who is responsible for what? Where are the interfaces? How does the communication work? So MQTT, I'm going to focus on MQTT because it is still the most commonly used application protocol for IoT. So for those who don't know what MQTT is, it is a bidirectional communication protocol. You've got producers and you've got consumers. Now, the interesting thing about MQTT is that it is fully decoupled. So if your subscribers are not connected or not online, it doesn't matter for the publishers. So the publisher can publish data. If somebody is subscribed to that topic, then the data is received. If not, then nothing happens. So this kind of decouples communication between publishers and subscribers. And of course, MQTT is just designed around reliability in unreliable networks. And we will see what at protocol level this actually means. Of course, it works at application layer, so it is an application layer protocol, and it works over TCP/IP. So you're still dealing with issues with a TLS handshake, and you're still dealing with certificates and so on. In terms of AWS IoT, I mean, this is a very simple diagram. Probably most of you are familiar. You've got the devices on the left-hand side, and then you've got the cloud. Now, this is overly simplified, right? So your devices are connecting to the gateway into AWS, and then starting to send data and be controlled by your backend solution, which resides here. The entry point is always AWS IoT Core. So you can actually see that if this here fails, then you have no connection from your application to your devices. So this is an important thing to remember. And we are going to focus on this, right? So why does this fail and how can we prevent it? So what can go wrong with the connection point that I mentioned to you earlier? Well, so there are multiple things that can go wrong. So first of all, for security purposes, ideally, when you're connecting your devices over MQTT, you would be using mutual TLS. So this basically means that your devices are the client in this equation, and the broker in the cloud is the server side of the equation. And otherwise, mutual TLS works pretty much as normal, right, with AWS as well. So the device is going to present a certificate, and then the cloud side is going to verify it, and then, of course, the cloud side is going to present a server certificate, and the device would verify the server certificate chain. Right, so what can go wrong? If your device, for example, is using the wrong SNI and doesn't know the domain that it needs to connect to, that is, of course, not going to work, right? TLS issues can also happen, right? So what this means is that maybe your device is using a wrong TLS version, or maybe the ciphers are actually not actual anymore, or maybe the certificate is too long and it can't be recognized by the other side. But these are all errors that once you recover from them one time, probably you can fix them in the lab before you go to production. But issues like latency in the network and TCP packets gone missing, this is something that you can't necessarily fix before. So you have this intermittent connection and packet drops and so on. So what do you do in that case? You just need to make sure that the connection keeps staying alive. So it might sound to all of you like a brutal approach, right? But it's really about just make sure you keep that connection going, right? So when the connection drops, recreate it, right? Reconnect over MQTT. This is how you would solve frequent disconnects. And I mean, of course, you need to build observability to figure out why exactly these problems are happening. But with the devices in the field, you're not going to send someone with a USB stick with a firmware upgrade to your devices. You need to be able to eventually connect to them so that you can debug whatever is going wrong. You also have situations where there is some sort of service maintenance, and AWS IoT also does this. It's happening, I don't know, it's not happening very often, it's not very likely, but it does happen. So you need to make sure that your device reconnects if it gets disconnected by the server from on the server side. Now, of course, if you're building your edge software and you don't make sure that your connection is reattempted with an exponential backoff, what's going to happen is that 1 million devices are going to connect at the very exact same second. And this is going to increase your cloud load extensively. I mean, of course, I've built a project with about 5 million routers. So what was happening is that those 5 million routers were sending data at the exact same time, and that data was reaching AWS and was causing throttling issues, right? So I mean, here, it's a very important thing to increase the service limit as a first point. But of course, the embedded engineers need to be also aware that they can build their application bearing in mind that there is load. Even if the load is not happening at edge, because at edge they have one instance and they're dealing with one instance. Right, so throttling due to service limits, first of all, try to make sure that the throttling doesn't happen if you can prevent it. If you can't prevent it, increase the service limits. Generally with AWS, there is a ticket. If you've got your on-prem systems, you also need to be aware and model your load properly. The other really interesting problem with IoT devices is the clock, right? So us as humans, we know what the time is. We can always look at our time, our watch. Devices sometimes don't have a real-time clock, and this is where you should implement an MTP client on your device to make sure that your device gets the time. If your device is using an RTC clock, it's probably not as good as NTP, and the reason for that is that every day, I believe there is a 1 second, it's 1 second back in time. So in time, your device would still kind of lose the synchronization with the real time. So you need to be careful with that, because if your device thinks that it's living in the past sometime, it's not going to validate the server certificate, and then at the TLS handshake level, the connection is going to fail. And of course, if you're building with AWS, ensure that you use unique identities. So each device should have its unique certificate, so that if there is an attack on your solution, then you know what device caused it, and you can also revoke its certificate or deactivate its certificate. Right. I did get a little bit into how to build resilience. I couldn't help myself until reaching to this slide, but actually, I hope this is visible from the back. Anyway, this is a little maturity model, right? So if you're using MQTT, MQTT can do a lot for you when it comes to the MQTT connection, right? So these on the left-hand side are features of the MQTT protocol that you definitely should use in your application. So MQTT provides a heartbeat. So what this means is that between the client and the server, there is some sort of periodical ping. So, you know, the client would ping the server would ping the client, and if the connection is not alive anymore, then of course the connection is going to be dropped. You also have this feature which is very interesting, which is called client takeover. So you need to make sure when you're connecting, you're using the same client ID on every new connection. If you're using the same client ID and the broker believes the client is still connected, but the client knows that it lost the connectivity and it tries to connect again, the previous connection is going to be dropped server-side and the new connection is going to be revalidated. So if you're using the same client ID, the client takeover feature is really good to use. Last will testament, I mean, this is just for every other consumer of the MQTT topics to know, before you go offline as a device, what do you want others to know about you? What is your last will, right? And persistent sessions, these are important for message transfer and for connection. So when you know that your devices might lose connectivity, you can connect to the broker with a persistent session. By the way, this is not AWS specific, right? So this is MQTT specific, and you can use it no matter what technologies you're actually building with. So if you're using a persistent session, then especially constrained devices, which don't have the resources very often to resubscribe to topics, right? Or to reestablish the MQTT connection fully. When they are connecting with a persistent session, if the connectivity drops, then they will receive from the broker the previous connection, which is stored, the previous session, which is stored on the broker side, right? But of course, at application level, you still have to build a few things. I mean, here I would say that this is as close to best practices in terms of coding that you can actually get. So make your code modular, right? So you know that you need an MQTT client library. So here you can use the device client, you can use the MQTT.js. Just make sure that you create your MQTT connection and you can manage it, right? So you can create it, you can destroy it, you can listen to MQTT events like connect or disconnect or error or interrupt. So always listen to those callbacks and act on those callbacks. When you're sending your data, make sure that you publish your data only after you know that your connection is created, because it doesn't make any sense, unless, of course, you're using persistent sessions. You have to make sure that your connection recovers. So any kind of error that you have, authentication error, authorization error, so on and so forth, do retry and make sure you implement sensible retries, right? Because if you have an authorization error, you might actually be able to fix it cloud side, right? So it might be a problem in the IoT policy. If it's a problem in the IoT policy and you fix it cloud side and then your device doesn't retry to connect, then it's obviously really bad, right? Accurate time we talked about. There are also tools that help with integration testing. So AWS has a tool called AWS IoT Device Advisor. You can use Device Advisor to test your MQTT connection and to test your publishing of data and so on. At message delivery, the same thing goes. I mean, MQTT supports QoS 1 and it supports QoS 2, and it supports QoS 0. If you use QoS 0, it means you don't care. It's a file and forget. So you don't care if the data was received and you have an acknowledgement. If you use QoS 1, then obviously the message can be transmitted at least once, but you get an acknowledgement. So this is a way to validate that your data gets sent. I mean, the way I used to do it, especially in the past when I was building IoT solutions, is have a little database at the edge. and then I was publishing a message, and then I was waiting for the acknowledgement. If the acknowledgement doesn't come, you store the data until you actually can retry to send those messages. But of course, this is if you care about your data. So yeah, buffering of messages for little connection loss is also very important. Persistent sessions does this, right? So it buffers the data for, for a little while. But if you have periods of long lack of connectivity, like days, you can't count on software buffering, right? So you need to actually build a database. Yeah. You also can optimize. If your edge is powerful, do some reasoning at the edge. Don't send all the data to the cloud. It ends up being also a little cheaper as well. And the last thing in the maturity model is really resilience of your application runtime. If you're using Node.js, and I did build a lot of IoT solutions with Node, actually. So, if you want to use Docker to manage the lifecycle of your application, you can do it. If you want to use PM2, that also works. So I've used PM2 as well in the past. You just need to make sure that your application stays up. Even if the operating system shuts down, when the operating system starts again, you need to make sure that your application restarts. And listen for those signals from the operating system to make sure that you act cleanly in your application. So when you know that the system is going to go down, just make sure that you terminate your MQTT connection, you disconnect cleanly, because the cloud side will appreciate that. You can build some observability if you do this. Right, now I'm just gonna really briefly go through device client, just to tell you that it is open source. You can have a look at it. It's available on GitHub. It's a modular application that follows the best practices that I talked about, and also a little bit more. You can also port this to different programming languages if you're not using C++. And it also, you can build it with Yocto. So my team has actually built a recipe for, device client on Yocto. So you can use that. It is in this repository called AWS for Embedded Linux. And it also runs in Docker. In terms of what it supports, it's basically pretty much everything that AWS comes with, right? So it supports, if you worked with AWS, then you know what I'm talking about. It supports fleet provisioning. It also supports secure tunneling from the cloud, and also secure tunneling from your separate application via a local proxy if you have that. It supports jobs and device defender. Now, the nice thing about how this application is built is that you can strip everything out, and the only thing that you have is the shared connection to IoT Core. So let's say you don't need anything else. You don't need jobs, you don't need shadows, you don't need anything. All you need is really this shared MQTT connection. Then you can just import that library and use it. In terms of what it works with, so it's basically designed to pretty much work here, right? So not the smallest microprocessors, because there you have embedded libraries, but somewhere in the middle. So it works on ARM, it works on MIPS, and it has also been tested with x86-64 and Ubuntu and Debian. There is also something more powerful. You probably know about Greengrass, which you can run on gateways. Right, so, I mean, this is a little summary of what we've been discussing. I'm not going to go through this again. What I do want to say is I want to show you some resources. You can use, the device client is available here. I've used MQTT.js in the past. It is a really good, quite powerful library. The version v1 of the AWS SDK was built with MQTT.js. The version v2 of AWS SDK has a common runtime. So, it's same runtime for C, same runtime for C++, and so on. Our team is actually working actively on blogs on Dev2. So we are doing a lot of open source. We are contributing to Yocto and to automotive grade Linux. So if you are interested in looking at the blog post on Dev2, if you have any suggestions as to what we should write about. So we are currently actively writing about FreeRTOS. We are actively writing about ExpressLink. We are also writing about this kind of work, right, with MQTT libraries and different other protocols. If you've got any ideas, reach out to us via Dev2. We also have a YouTube channel. We have recently started live streaming. So there was an event in Nuremberg called Embedded World. So this is a major conference in the embedded space. So we've also been live streaming from there, and we've got this content on YouTube if you want to, have a look at that. Right. And of course, if you're interested in Yocto, do check out this Meta AWS repository. This is all with recipes for different AWS services to run in embedded Linux. Now, if you want to see an implementation of a resilient MQTT client, this is work I've done about 2 weeks ago. It's using the AWS IoT SDK, so it's located in this repo. And it's also using ARM virtual hardware to simulate a microcontroller device. So you can also have a look at that. Right, so this has been my presentation. Please ask me questions if I skipped through a few things quite fast. And thank you very much for your attention today.
Thank you, Alina. Great talk. Allow me to give you the trophy that we've been giving to speakers. Thank you very much for being here with us. We hope you're going to enjoy Florence in the next few days.
Absolutely.
And the good food, because it's amazing around here. So, are there any questions in the room? Any? Let's see. Okay, we're a little bit shy. I know you want to ask a question. Come on. How come not? Okay, there we have it.
Okay, thanks. Is this library usable without Amazon AWS? Like, I can host a server open source and then use this library to connect with that?
So the device client, the first one, is integrated and configured with AWS. You can use part of it, you can use different components, but you can't, it doesn't make sense to use the full library outside of AWS. However, MQTT.js, for example, which is the most popular JavaScript library, that one you definitely can use. If you want to use another programming language that is not JavaScript, you can have a look at Paho. So this comes from Eclipse. But for JavaScript, my experience with Paho is that it doesn't support mutual TLS for JavaScript in the JavaScript implementation. So this is where it gets a little tricky if you want to do MTLS. If you want to just use basic auth, for example, password and username, then you can also go for JavaScript Paho. And I believe Mosquito also has a client library in C that you can also use.
Thank you. Any other questions? Let me see. I'm not seeing those guys and girls over there. No. Okay. So, yeah, I think we're good. Thank you very much, Alina. It was a pleasure having you here.
Thank you.
Thank you.